Rather than by drawing a graph, we can also solve a system algebraically, which just means we can solve it by doing algebra. We have two algebraic methods to solve a system. The first one is the substitution method, which has some advantages, including that it's kind of easier to wrap our heads around what we're doing. The big idea of the substitution method is that we can always replace a variable by something that's equal to it. So typically we do that with numbers, but there's nothing that says that we can't do it with variable expressions. So we're going to use the substitution method to solve this system of equations. And while we're doing it, we're going to review the steps, just step by step. So our first step is to solve one of our equations for one of the variables. Either solve it for x or solve it for y. We will typically choose to use the substitution method, especially in systems where this is already done or easy. In our example, this equation is already solved for y, so there's no work to do at step 1. Our second step is to substitute that equation into the other. Here's what we mean by that. This equation tells us that y is equal to this expression. We're going to take the second equation, but everywhere we see a y, we're going to replace it by this expression, 3x plus 5. So I left 3x alone because that doesn't have a y in it. In 2y, I replaced the y by 3x plus 5. And then I left 1 alone because it doesn't have a y in it. Now notice that the equation that we've just written is an equation in one variable. This is the kind of equation that we've known how to solve for a really long time. So now we're going to solve it. Let's see, first I need to distribute the 2. Then I'll combine my like terms. I'll subtract 10 from both sides and divide both sides by 9. And we get x equals -1. That's not the entire solution to this system. That's only one part of the solution. We now have the value of one of the variables. Now we're going to plug that value into one of our original equations to find the value of the other variable. Now looking at my two original equations, I see that this equation is going to give me a much easier job if I plug x equals -1 into it to find y. We'll have y equals 3 times -1 plus 5. So y equals -3 plus 5. Y equals 2. That's the other part of our solution. Our solution is x equals -1, y equals 2. Now, this process is not difficult, but it is time-consuming and error-prone. So once we find our solution, we should check our solution. And fortunately, that's very easy to do. Whichever equation I just used to find the second value, I'm going to plug my values into the other equation. So to check, I'm going to take my second equation and plug in x equals -1 and y equals 2 and see, does that equal 1? -3 plus 4 equals 1? Yes, that checks out. So my solution is -1, 2. And I know for sure it's correct because I've checked it.